Yesterday we took a look at adding and subtracting square root expressions, which is just like adding and subtracting like terms with variables in that if they don't match, they don't have that same last name, they cannot be combined. Now today we're getting into multiplying square root expressions where it's just like variables again, where you can combine them even if they're not alike because they will just change each other. So step one is going to be to simplify any and all radicals. And so in the case of A, I see that with square root of 8, that's the same thing as the square root of 4 times the square root of 2 times the square root of 2, which means that square root of 4 is 2, so I have 2 square root of 2 times the square root of 2. Our next step is going to be then to multiply all our inside stuff, or all the stuff underneath the radical, with inside stuff, and anything outside the radical with anything outside the radical. So I like to remember that there is a 1 out here. And in doing that, I see that my 2 times 1 is 2, and my square root of 2 times the square root of 2 is the square root of 4. Then my step 3 is going to be cleaning it up and combining like terms. Well, I know that the square root of 4 is 2, so I have 2 times 2, which is 4. Now, one thing that some of you might be wondering is why I didn't just say the square root of 8 times the square root of 2 is the square root of 16. Square root of 16 is 4. You can go that route as well. That is fine with me. Please go ahead and do so if you feel more comfortable with that. For B, we've got the square root of 5 times the square root of 5, which we know is the square root of 25, which equals 5. For C, we have the 5 root 15 times 5. Well, I'd rather not take 15 times 5, so I am going, but I don't have a choice because 15 is not a perfect square and there are no perfect square factors. So we have 5 times 1, which is 5. Square root of 15 times square root of 5 is the square root of 75. I know the square root of 75 breaks into square root of 25 and the square root of 3. So that means that I have my original 5 from up here times the 5 from the square root of 25 times the square root of 3. That means that my answer is 5 times 5, which is 25, times the square root of 3. Looking at the next example, I would much rather break this down. I know that square root of 2x cubed y is the square root of 2 times the square x squared times x times y. And I know that square root of 4x to the 4th is going to be something that is also already a perfect square, so I'll leave it as such. Then I'm going to go ahead and take my square roots. Square root of 2 stays under, square root of x squared is x, and then I'm left with 2xy on the inside. 4x to the 4th, square root of 4 is 2, square root of x to the 4th is x squared. When I go ahead and multiply what's on the outside, I get 2x cubed square root of 2xy. Like I said, if you wanted to go through and say that that was the square root of 8x to the 7th y and then simplify it, you would get the same exact answer. In the case of E, you will notice now what you guys were trying to do in 1.5 day 2. If you saw parentheses, and that is FOIL, here we have the plus signs, so we do need to FOIL. When I go ahead and do that, negative 3 times 4 is negative 12. Negative 3 times 2 square root of 2 is negative 6 square root of 2, because negative 3 times 2 is negative 6. 5 root 2 times 4 is 20 square root of 2. And 5 root 2 times 2 root 2 is positive 10 root 4. Now we can go ahead and simplify. We have the negative 12 still. Negative 6 root 2 plus 20 root 2 is 14 square root of 2. And 10 root 4, square root of 4 is 2. 10 times 2 is 20, so plus 20. I can then go ahead for my final simplifying to get negative 12 plus 20 is 8 plus 14 square root of 2. Your job now is to go ahead and complete these U-try problems and bring your questions with you to class tomorrow. And don't forget to write your summary.